quiz 3. So this is a quiz 3 and it's also a review. So it is also a review for the first 9 weeks exam. So again, it's a quiz 3 and a review. The 9 weeks exam, again, the 9 weeks exam consists of percent mixtures and radicals, and it also has exponent questions and simplifying expressions using the PEMDAS, the order of operations. Quiz 3, again, quiz 3, it's only on these 3 things. But that's the bulk of the 9 weeks exam is these 3 things, and there's only 3 questions on the other stuff. I think I put 2 exponent questions and 1 order of operation questions. So by doing this, you should be fine for the test if you follow this review. Okay, let's get started with this. Why do I have 3 boxes here? This is a mixture problem. They're always going to give you 3 things. You can have more than 3 things, but for this class, I've only seen where they mix in 3 things. So they're mixing the... So let me read the question first. How much of an alloy that is 20% copper should be mixed with 200 ounces of an alloy that is 50% copper to get an alloy that is 30% copper? So if you notice, there's 3 things. There's this, there's the 50%, so there's the 20, the 15, and the 30. That's why I have 3 things here. And this is our alloys. The percent means the concentration of copper in the alloy. Alloy means that it's gonna have copper and other minerals mixed in, and that make this material that's only 20% copper, and that one's 50% copper. And when you combine these two, they want you guys to get something that's 30% copper. So alloys have a mixture of things. Okay, the 20% copper, are they giving us how much? No, they're asking, if you notice, how much of this. So we're gonna name that the X number of, and it's in ounces. Yes. All right. Do we get something for the 50%? Do we get how much? Yes. So 200 ounces. So we know we have 200 ounces of this. And how much it is? This is just a combination, the addition of this number of ounces plus this number of ounces. And that's how many ounces of this at the end we will get, which makes sense. You're mixing these two, you're gonna end up with the addition of these 2 amounts for this one. That's logical. You need to end with these 2 amounts. Okay. So now we know that. Now we're gonna start the equation. So you're gonna have to create the equation. So I should write it down maybe. Create the equation. So this was the drawing. I did the drawing for you on the test. You're gonna have to do it on your own. This is the drawing. It simplifies things and then create the equation. How? Well, we're gonna multiply the concentration of copper times the ounces, which is X, we don't know, plus concentration of copper for these times the ounces equals the concentration, which is 30 times the ounces of this, which would be that. Okay, I forgot to mention one thing on the plus. When you're mixing, you're adding. So you're mixing these two, so you're adding them together. To get, that means equal. You want to get that. So you should know they have to be equal. Okay, now let's go back by the equation. So again, I multiply the concentration times the ounces. Now that one stays the same. That one gives you hundreds. 0.5 of this is 100. That one you're gonna have to distribute to both terms inside the parentheses. So you're gonna have x plus, I'm gonna put it in parentheses here so that you know what's happening. So let me rewrite it. Plus 30% of 200 gives you 60. Now, once you get to this step, we start combining, bringing stuff from one side to the other. And we're gonna start with the x's. So we're gonna combine the x's because they're like terms. But you're gonna have to do the inverse by solving the equation. You do the inverse to bring it to the other side. So this becomes 0. You bring down the 100s. 0.3 minus 0.2 gives you 0.1 plus the 60. Now combine numbers, but you bring this one to the other side. And you could have gone either way, from here to here or from here to here. It didn't really matter. The only difference is you would get negatives if you go the opposite way. You would get negatives here and here. That's why I went this way, that to avoid the negatives. You bring this one down, and that one gives you 40. And then you divide. The inverse of multiplication is division. When solving equations, that becomes a 1, so that's just an x. And that gives you 400 ounces. So how much of this alloy do we need? We need 400 ounces. So we need 400 ounces of 20% copper alloy to be mixed with the 50% copper alloys to get the 30% copper alloys. So this is the answer. 40. So we need 400 ounces of that. If you want to know how many ounces of this, we have just add these two. The x is 400, like I said, and then plus this 200 gives you 600 ounces at the end. This is the end result. It gives you 600 ounces of this. And that's it for this type of question. Just follow that. Let's move on. These are the percent questions. Percents. Okay, that one's talking about, let's read it. By doubling each dimension, the area of a parallelogram increased from 36 square centimeters to 104 square centimeters. So this is equal to 36 square centimeters. And the area of this is equal to 104 square centimeters. So that's the increase. So what are they asking? Find the percent of increase. So this is the question. Find the percent of increase. And I gave you the answer for the quizzes right here, but I'm doing it for you so you won't need that. Okay, how do we find the percent of increase? You're gonna get something like this in the 9 weeks. Step 1 would be to find the increase first. Step 2 would be to find the percent of increase. Alright, so this is percent. So what's step 1? You're gonna divide, you're gonna subtract the area of the bigger one minus the area of the small one. And that is gonna give us a difference of 108. Okay, so now we have the increase. This is the increase. Now we're gonna place that increase for step 2 on this side of the equation. And it's equal to what? The percent. I'm gonna put an X because we don't know what the percent of what times of the original area, which is 36. So in words, this would be the increase equals the percent times the original area. So this is one little square, this is another square, this is another one, and this is another one. That's how I look. The increase, which is this, equal to the percent that we don't know, times the original. Okay. Once you have that, all you have to do is divide. That becomes a 1. And this becomes a 3. Okay, let me explain one thing here. So now we know it's a 3 point, I'm gonna put 0, 0. That's the increase. So it had a triple. But if you're trying to find the percent, you're gonna have to move the decimal, even though it's a little bit different from the other ones that we've done. It's usually something less than 1 when you move the decimal. In this case, it's not a decimal, it's just the digit number 3, the number 3. But you still have to move the decimal to find out the percent, which would be 300%. When you move that dot here, it becomes a 300%. Okay, what does it mean 300%? That area went up 300%, basically kind of like triple. It tripled its original area from 36. It tripled the area by 108. If you multiply 36 times 3, it gives you 108. So it tripled, that's why we have a 3, but in percent it means it had an increase of 300%. So hopefully that makes sense. Let's go to 3. A gasoline station decreased the price of a 95-cent cola by 15%. Find the decrease in price and the new price. So this one is going to have 2 steps. So step 1, decrease in price. That's what they want. In price. And step 2, they want the new price. So how do we find the decrease in price? It's telling you here that was the original, and they decreased it by 15%. So you're gonna get the 0.95 times the 15%. When you multiply these two, it should give you the 15% of that, and that's how much it went down. And that's 0.14 cents. That's how much it went down in price. So that's the decrease in price. The new price, all you have to do is get the original minus the decrease in price, and that gives you 0.81 cents. This is the new price. So this is the new price, this is the decrease in price. Okay, the last one for this one's a student at a University of New Orleans makes money by buying and selling used cars. Charles bought a used car and later sold it for 20% profit. So this is the original cost or price, original cost of the car. It doesn't really tell you, so that would be the X. We know that he made a profit, so plus the profit. So you're adding to whatever the car cost plus the profit. What was the profit? The profit was this point zero, no, not point zero, 0.20 times profit of what? Of the original. So this is the original plus 20% of the original. If you, that's how much you're adding to it to know how much he sold it for. How much did he sell it for? He sold it for this amount. So that one goes on this side. So again, this is the original cost, we don't know. And this is how much he sold it for. So original cost, we don't know, plus the profit of that original price, which is 20% of the original, and sold it for this. Okay, there's a 1 here. So remember, we're going to combine coefficients. 1 plus 0.20 4680. So this gives you 1.20 x equals 4680. So now you divide 1.20 because we're kind of going backwards. When you divide these two, it gives you 3,900. That's how much Charles paid for the car. So Charles paid this, and then he plus the profit, the 20% of that gave you that. So it makes sense. That's how much it cost the car, and that's how much he sold it for. And then if you want to know the profit, you would have to subtract that and minus that, but we don't need that for this question. Okay, the last one. This is to do with radicals. Let me write a note here. This is a reminder. When you have even roots, so if you have an even roots, meaning 2, 4, 6, 8, and so on to infinity. For example, the square root of -4. When you have something like this, there's no parentheses here, there's not an exponent. When you have this, or maybe let me give you another example also, the 4 root of -60. These two, they're not real because this is even. You cannot have negatives inside. Not a real solution. Not a real solution. Okay, it's not always the case. For example, you can have, this is another note, you can have the square root of -2 square. Or you can have the square root, the 4 root of -16 to the 8th power. This is an 8. Okay, this, when you don't have a number here, remember it's always a 2. If it's bigger than 2, you will get the number in there. Okay, this one does have, if you notice there's a negative, but this one has a parenthesis. That one didn't have anything, it was just a negative something. So that one will not have a real solution. For this one, it does have, because you can actually solve the inside first. What's -2 raised to the second power is just -2 times -2. -2 times -2 gives you a positive number, which is 4. And we know the square root of 4 is just 2. So you see, this one doesn't have a solution. That one, even though it's a negative, but it has an exponent. It makes this a positive at the end. So it does have a solution. Just be careful with this. When there's a parenthesis, don't assume it doesn't have a solution. You still have to go through this. This one, if there's a parenthesis, that one will also have a solution, because if you multiply negative 16 8 times, this would give you a positive number, and this is how you find it. So it's gonna give you a huge number. So negative 16 raised to the 8th. So this one gives you a huge positive 24294967296 429,496,7296. So you see, when you raise this to the 8th power, the negative goes away, it becomes a positive number. So even though it's even and it originally had a negative, it wasn't actually a negative, it was a positive because of that 8. And we can make this one look like this one again without the negative, because we know it's just the same. So now we don't have the parentheses, we don't have the negative, because we know it's positive. So when it's like this, there's no parentheses anymore, you can actually divide 8 divided by 4 to find the square root of that, which would be 16. 8 divided by 4 would be 2. Right? 16 to the second power, and you can actually simplify that, which would give you 256. Those two are correct. That's just notes so that you guys compare. Okay, this is only with even numbers. Even roots. When you have odd roots, you don't have to worry about this. You can have negatives, you can have parentheses and divide, it doesn't make a difference. Okay, let me split the cube roots here. I'm gonna split it a couple times. So cube root of 64 times a to the third power, and this would be the cube root of b to the 9. I'm gonna split it one more time. The top part, cube root of 64 times the cube root of a to the third over the cube root of b to the 9. Again, like I said, there's no parentheses. Plus, with cubes, you don't have to worry about parentheses or any other stuff. You can just divide like this. For example, this one. This would just be 3 divided by 3. This one would just be 9 divided by 3. This part, you need to find a number where you multiply it 3 times, because it's cube root. Find a number where you multiply it 3 times. That would give you that 64. Okay, and that number would be 4. 4 times 4 times 4 gives you 64. I'm going to write it over here, the notes. When you multiply 4 times 4 times 4 3 times, it gives you 64. So we know the cube root, cube meaning 3 times, 64 would be 4. So we can actually just write a 4. That would be the cube root of 64, which is be a 4. Then divide this. Let me write it like this first. So the final answer would just be negative, because that negative what's outside doesn't get affected. And then 4, 3 divided by 3 would just be 1. 9 divided by 3 just be 3. And that would be the answer. Again, with cubes, all you have to do with letters, just divide the exponent by the root. You can do that with evens if there's no parentheses like here. If there's no parentheses, you can do the same. But if there's a parenthesis like here with the negative inside, you need to be careful. You need to simplify that first. Get the positive number, and maybe using the calculator, you can find the square root of that big number. Or if you remember, if you remember that you can make it like this without a parenthesis. Once you have that, you remember that you can divide because there's no parentheses, there's no negatives like this. You can just divide. Again, with our roots, you don't have to worry about it. You can do it from the beginning. And that's all. Thank you, guys.